All right, can people hear me? Well, let me know. Where office hours have kicked off for Unit 1. I see that Timur is here. Someone is asking if there's no office hours today. There is office hours today. In fact, let me know if you can hear me. So I know that I am transmitting. Yes, all right. You able to hear me? Thank you. That's good to hear. All right. So, welcome to World Quant Office Hours, Unit 1. Let's see who is joining us today. All right, I see. Yep, we got another confirmation, loud and clear. That's good to hear, right? Loud and clear is good to hear. All right, and I should open up my whiteboard to put the agenda, but the agenda continues on to be the DW mini project agenda. And of course, as we work that through, we get more comfortable working with Pandas. So DW mini project. We're on pace to wrap up our discussion with that mini project by the end. At the end of this week. So the last 2 weeks we can do cool stuff. Not like the stuff we were doing isn't cool, but things like version control, Flask, web applications. What Flask allows you to make web applications, working with APIs, working with web APIs, kind of round ourselves out in the things that we've seen in this course. And all right, so looks like Tom can hear me over the UK rain. All right, so I guess it's raining out there in the UK. Sounds like a song title, Rain Out in the UK. All right, so let's see who else is with us. I see Lyndon Smith is here. Hello, Lyndon. I see Shakiba is here. Hello, Shakiba. Welcome to Office Hours. Let's see who else is joining us today before we kick it off. And do let me know anything else to throw on the agenda so we can go ahead and get started. I don't know, Tom, that you were based in the UK. For some reason, I thought you were based in the US. Maybe I was off. I guess I was off. I've never visited the UK, but I do want to go, perhaps when this is all over, right? I do want to visit the UK. At sometime I will. See, Paulo is here. Hello, Paulo. Omadar is here. Hello, Omadar. I see Edward. Someone is Edward is asking about when to apply to Unit 2. You should apply to Unit 2 right now. You should apply before the end of the deadline. You don't need to have completed Unit 1 to apply. It's just that after the deadline, you need to apply before the deadline, and you need to make sure that the deadline for the assignments that you do complete this module. So when you go on to apply, when you go to the apply website, make sure you log in using the same account you used to apply, and make sure that you check the box of Unit 2. And I stress that because there's some people who forget to check the box for Unit 2 and they end up being in Unit 1 again. So we don't want that to happen. Make sure you log in with the same account, because then we check in our database that, oh, you are currently in the course. So you are currently allowed to apply to Unit 2. And then once we do admissions, which is after the deadline of the assignments, we say, hey, you sure enough completed Unit 1. You're allowed into Unit 2. So please do so as soon as possible. It's the same application process, so that might be a little annoying, but you've gone through the application once. You can go through it again. The criteria for getting to Unit 2 is completing Unit 1. So please don't wait until the last minute. Apply to Unit 2 as soon as possible. You can, in fact, apply to both Unit 1 and Unit 2 at the same time. You can check both boxes. So if you don't complete Unit 1, then you won't get into Unit 2, but then you will put in an application for Unit 1, so you might get into Unit 1 again. But of course, wrap up Unit 1 work. Deadline is 2 weeks after, I think December 4th was the deadline. So yeah. All right, so Northwest UK, the wettest part, Northwest UK. Okay, I don't really know much of my UK geography, right? If I were to draw the UK. Horrible drawing right here. Alright, so I guess this is Scotland, and this is, so So this is Northern Ireland, and I guess Wales is here, right? Wales, and here is England, and here is Scotland. That's my my drawing of the UK, and I guess you live, I guess, somewhere here. That's okay. Thomas saying they only saw the Unit 1 box. Manchester. Okay, yeah, I've heard of Manchester. All right, so regarding, let's see. I only saw a box for Unit 1. Do make sure that you log in with the same account you applied. Maybe you didn't do that, because that's how we figure out whether whether you're currently in the course. So do make sure that you log in the same way. If you still get no box, then that's a problem. Do let us know if that's still the case. Let's see, Paolo is saying, in the lecture of pandas, we learned about the index of a series can be numbers, strings, timestamps, or hashable Python objects. What would be an example of a non-hashable object, right? Let's go ahead and put that on the agenda. Examples of a non-hashable object. Non-hashable object. Do I need to have all the questions finished before I apply? The answer is no. We just check whether you're currently in the course or you're an alum of Unit 1. And that's how we allow you to apply Unit 2. So the question is, what are some examples of non-hashable objects? So there's a couple of those. In fact, let's go and open up a new notebook so we can have a discussion of what are things that are possible. Rename this Office Hours, November 3rd, 2020. All right, so anything that is mutable is not hashable. Anything that can change, can mutate, is not allowed to be hashable. So hash refers to taking some object and returning some value with it. So for example, I can hash hello and I get a value. I can hash, let's say, a number like 56 and I get a number out of it. I'm able to hash integers, floats, strings because those are immutable. Those are immutable objects. Right, you cannot, in fact, I can have my string equals hello. And what if I want to change the last index, the last value to be, let's say, a question mark? Well, I get a syntax, well, that should be in quotes. And I get a type error. String object does not support item assignment because strings are immutable. So strings are hashable because they are immutable. Tuples are hashable. I can hash a tuple so long as the members are hashable. So there you go, I hashed a tuple. But lists are not hashable. So if I try to hash a list, I get an error, type error, unhashable type list. So anything that makes sense because lists can mutate. We can mutate lists. We can modify them so they are not allowed to be hashed, and thus they can serve as keys of a dictionary or elements of a set. And this makes sense because you can imagine that underneath the hood, pandas, remember what we said about pandas, you can view the row labels and the column labels as keys. Would make sense there's a hashing criteria to serve as keys. So things that are hashable, things that are hashable, and this isn't an exhaustive list, but integers, floats, tuples, strings. Things that are not hashable are things like lists, dictionaries, and sets. So that's a quick run through of examples of non-hashable objects. Do let me know if there's any follow-ups about hashability and what it means to be hashable and objects that are hashable. And you can always check, right? You can always check if you're uncertain. You can always run them through this hash function and see what happens. You get a type error on a hashable type, then that's a proof right there. All right, do let me know any follow-ups. Let me look at currently in the chat here. All right, Tom. So do make sure you're able to see Unit 2. I do want to make sure that that is the case for you and for everyone in general. I see that Timur is saying, can I ask you a question, as I did have an opportunity to ask, but I would like to know if after Unit 2 we must study something else or we can be ready for real-life projects. I believe if you go through Unit 1 and you go through Unit 2, you are ready for, quote, real-life projects. I really do think that's the case. Of course, practice makes perfect, but I really do believe that is the case as you go through Unit 1, Unit 2. I haven't been doing the office hours for Unit 2. Someone else has been doing the office hours of Unit 2. I am the voice of Unit 2 videos, though. And I believe what the things they are doing is they're working on, towards the end of the course, they are working on some machine learning competitions to get practice in building machine learning models. So I really do think that as you go through Unit 1, Unit 2, that you are, quote, ready for real-life projects. In fact, I really strongly believe that after the end of Unit 1 and going through those extra materials that I plan to talk about in office hours for the last 2 weeks as we finish up this mini project, I do believe that will make you more well-rounded to tackle real-life projects. Of course, not including machine learning, but machine learning isn't everything in life. People seem to think so, but that is not the case. All right, let me know, and if there are any questions, anything else we want to bring up before we dive into the DW mini project. So do let me know. I'll keep looking at the chat for any follow-ups. Okay, so where we left off was we calculate the standard error per practice. Calculate the standard error per practice, and we are good to go from there. And then once we calculate the standard error, then we can calculate the z-score. And if I look at the equation, it's the numerator, which is the relative opioids per practice divided by the standard error per practice, and that should get my opioid score. So now I have my opioid score. In fact, I can take a peek at that. Let's go ahead and take a peek at that opioid score called head. And now we have the z-score for each practice. All right, Tom, you're able to see Unit 2. Glad that that working out. I was a little scared that might be something wrong with our application system. So yeah, make sure you are signed in with the same way you applied to Unit 1. Right, because if you want to know, we have our web application for submitting applications, and so this is our web application, and we have a database. And that's how we can know when someone signs in. Then we tie that account, we look them up in our database, and we check whether they're allowed to see the Unit 2 box. A little behind the scenes of what's going on there. Okay, so we got the opioids score, and one of the things we look at here is we're sort of ready to go, but we need to format our answer to be practice name, the z-score, and the number of prescriptions. That's what we're looking for in the solution. We have the practice z-score for the practice code, but we need the practice name in the formatting of our results, along with the number of prescriptions. And one of the things is that we got to create a variable called unique practices, because if you read somewhere buried in this description here, note that some of the practice codes will correspond with multiple names. In this case, use the first match when sorting names alphabetically. We saw this problem earlier where there are multiple practice codes that correspond to multiple names. Practice code might correspond to multiple names, so we want to go ahead and fix this. We want to create a mapping where we can go from a practice code to a single practice name. So in other words, we got to drop duplicates. We got to be able to drop duplicates. So that's what we code out. That's what we should code out right here. Unique practices. So we call practices, and we sort values by name. And then we could proceed to drop duplicates in the subset of code. In other words, we're going to consider a duplicate as having the same code. And which one should we keep if we do find duplicates? Well, we want the alphabetically first, and we had sorted it, so we can say keep first. So now we have a mapping of unique practices. Then all right, so I can take a look at this, unique practices. And I got the code and the name. Now let's see what we've got here. We've got a data frame with the code along with the name of the practice. And now we have a series that has our z-scores. Anyone want to recommend a convenient way I can add that column readily to this data frame? I have this data frame. I have a series with the opioid score. How can I easily include that column to this result here? Well, this column has the indices are the practice codes. And these indices don't appear to be practice codes. I'm not sure what indices these are. I guess they are the zero index, right? We're going to do a merge. And we can do it, we can do a merge. And however, the merge would work out. In fact, I will show you the merge. I want to merge. And I say, what I call it, opioid score, and I can say left on code and right on index true. So in other words, I want to merge this this data frame with this series. The merging criteria on the left is the code. The one on the right, since it's a series, it's the index that has the practice codes. So we say merge there, and I get an error. It says cannot merge a series without a name. So that name looks like this name. This series doesn't have a name. Well, no problem. I can add a name to a series. I can say name, and I can call this z-score. So now I can merge it together. And let's check that out. And yeah, it looks like that worked out. It looks like I have the z-scores in there. So that's one way to go about it. And while I don't want to discourage the use of merge here, another way to merge a column to a data frame is by exploiting the fact that if I can take unique practices and I were to set index to be code. So I can say unique practices equals unique practice dot set code, and then I can say unique practices z-score is equal to opioid score. Then I can run this here. I can say head, and then I get an error. Not an error, but I get NANs. Maybe those don't have z-scores. That might be the case. Let me think about that. Let me run that cell again. Yeah, maybe there's just some practices that have NANs. Because there might be some opioid scores that are missing those values. So I'll leave those be, but this is a different way I can merge that in. So we can use merge here, or we can exploit the fact that if we're going to add a column to a series, we can set the index to be the same field and then do the assignment right there. Okay. So now we have the code, so we have the name, we have the z-score, and what we are missing is the number of prescriptions for each practice. So I want to figure out the number of prescriptions for each practice. There are multiple ways to go about this, but I want to suggest a way I can figure out the number of prescriptions for each practice. Yeah, I can group by practice. I can do that. I say group. I can say group by practice. I can say one of those. I can say maybe z-score and say group by prescriptions. Take my scripts. I can group by practice. And then I can select one of those. I can say count. I think it's just practice. There we go. And I can calculate number of prescriptions for each practice. So I can go ahead and just index something like B&F code. And now I have the number of prescriptions for each of my practices. However, a different way to go about this is every time you find yourself asking, I want to know how many times practice appears, how many times each unique value of practice appears in a given column, I can use value counts instead. In other words, I can say scripts, and I can say practice, and I can say value counts. And this here returns, it's sorted, sorts it by default, number of times each unique value of practice appears. So there's two approaches to group by and count. However, I find this a little bit cleaner. So I will use this method here. So now that I can figure out the number of prescriptions for practice, and notice the index is practice code, and this index is still code, oh, that means I can easily add two unique practices number of prescriptions. And there we go. Now we've added the number of prescriptions for each of the practices. And these still have NENs because I guess they do not appear in our results. We'll see if this gets us into trouble as we submit to the grader. But now we have the counts and the z-score. So we have counts, z-score, and finally the name. I think we have all pieces of information to pass to the grader. Z-score, the number of prescriptions, and the practice name. So we'll go ahead and say result. So a quick way to submit for the submission to the grader is we can just select what the grader needs. And the grader needs the name, it needs the z-score, and it needs the count. And of course, I think it wants the top value of the z-score, right? The top 100, the largest z-score. So it makes sense that we have to sort by values. So we can say sort values and say by z-score. And by default, it does from ascending order. So we'll set that to false. And now we take a look at unique practices just to make sure. We sorted by top z-score. I think we're ready to submit to the grader. Let's see whether we're going to run into any trouble and how we can fix that. I think these numbers are a little tad too high. Got to figure out what's going on there. So we get, we'll call this anomalies. Make sure that what we're going to pass to the grader is what we have. So name, z-score, and count. And let's make sure I spell this correctly. Pass it to the grader. And let's see what is going on. Because I got to submit the top 10, right? So I can say head 100. Head returns the top n number, so I can set head 100, submit to the grader, and I get a score of 0. So there's something fundamentally going wrong in our code. In fact, the default answer we provide is National Enhanced Services, value 11.6 and 7. And we don't even see that, so there's something wrong with this. Perhaps my z-score is I think my z-score is just a tad too high. Right, I got 107, seems a little too high. Seems like I'm doing something wrong there. So let's go ahead and examine. In fact, I'm going to go ahead and look for this field. I'm going to copy that. Yeah, z-score seems really high, yeah. So let's go ahead and do unique practices. And let's query where name is equal to enhanced services. And there it is. So the count is correct. The z-score is about 9. So there's something going wrong here. And what I think is the issue, and I made a mental note of this when we're working on this together, is, let's see if this fixes it. Remember when we were checking whether a drug was an opioid or not? So that's what we did there. We checked whether it's an opioid. And then we merged. We merged in the prescriptions along with this chem data frame that had whether a drug is an opioid or not. And we did an inner merge. So in other words, if a given prescription, we don't have a match of its BNF code, then it was excluded in the analysis because we did an inner merge. Remember in how inner merges, they have to be a match between the left and the right. So if they don't have a match, we don't have that record. So what I think is happening here is that there are certain records that I'm losing when I perform the inner merge because it has no matching BNF code in the chem subfield of the chem data set. I think that's the problem. So I'm going to make the decision that if there isn't a drug, if there is a prescription in my scripts data set, that there is no match in the chem sub data set, the chem field data, this chem data set. In other words, there is no match for BNF code and chem sub. I'm going to call that is not an opioid. So what I'm going to do here is, let's see if we can fix this. I'm going to say left, a left merge. So it's include all the records in scripts. But the problem here is that there's going to be missing values. In fact, I can say is opioid, is null, compute the sum. So this here returns a boolean of whether it's a missing value. We'll compute the sum, and this will be an easy way to tell us how many prescriptions we are missing. So it looks like there are about quite a few, about 100,000 prescriptions that we're going to lose if we perform an inner merge. So we got to replace those missing values. And so should I replace the missing value of is opioid as true or false? Any suggestions on how I should replace those missing values for the opioid field if I couldn't find it? Should I say true or should I false? What's a good replacement value? Of course, this is a judgment call. Yeah, we should replace them with false. So what I can do here is I can use the fill NA method. Scripts chem is opioid. Fill NA. And fill it with false. The argument there is that if I couldn't find it in the chem sub, it's probably not an opioid. So let's fill those with falses. And now let's just double check. Scripts chem is opioid. Let's see where that is null. Let's sum that up, and that should be 0. And so now none of our prescriptions have zeros, have any missing is opioids field. So then we'll go ahead and repeat the process. Oh, I'm getting different numbers now. Getting different numbers, if I recall from before. Different numbers. Maybe this will fix my issue. Okay. Okay, so I look at this National Enhanced Services, and the z-score is about 10, with a count of 0. Let's see how well this works out. And I still get 0, so there might be something wrong in my math. And I do have messy code, so I do apologize. So it's just once counting the records before giving a high z-score. So there's, let's see. If I sort, let's see my top results, how they look like. Those z-scores are still high. Those z-scores are still high, which tells me that maybe I'm calculating the z-score incorrectly. So let's see if let's figure that out. What is going wrong there? So if my z-score is too high, then maybe my denominator is too low. That's one way to think about it. Oh, sorry if I'm zooming all over the place. So this is what we're calculating. So the z-score might be a little too low. Sorry, too high. So this standard error might be small. And let's see. Opioid scores, scripts. Let's see, where did I calculate the standard error? I don't see where I calculated the standard error. Yeah, I'm thinking we may not have used the square root. I think that's what happened. However, I can't seem to find, there. I didn't use the square root. Right. So notice how let's see, let's fix this. Let's fix this first before I prematurely declare victory. Let's run this here, and our code is messy. I got a value 0.02. So my z-score is now a little too low. So I'm glad I didn't declare premature victory. So let's see. Here is the standard deviation divided by the square root of the count. And that should be, that should be correct. Square root, standard deviation. Is opioid, standard deviation, relative. Something is going wrong here. So, since our code is messy, how about we start from the top, but we know what we're going to do. So let's see if that fixes that. So I say chem, and let's go to reading chem. So chem is equal to pd read CSV, and the DW data, and chem GZ. And do we have to give that a header? No, it should be fine. Run that. And let's see, and then we can say chem sort values, chem sub, so let's drop those duplicates. That might be an issue. Drop duplicates on subset chem sub. Let's keep the first. I should assign that to a new name, or overwrite the reference. Let's figure out this opioids. So then it's flag opioids. I say chem is opioid. Chem name string lower. And if we fixed the z-score problem, but now it's a slightly too low, which might suggest we might be undercounting opioids. So call lower, and I'm going to say contains. I'm going to do this slightly different. I'm going to use regex here. Join and opioids. And let's see, it's called join. And now I can say scripts with chem is scripts merge chem sub is opioid. Left on VNF code, right on chem sub. And then that's going to have some missing values, as we discussed before. So I can say fill NA with false. And a syntax error, so probably something fundamental like an equal sign, not having an equal sign. And spelling counts. Opioid. And now my kernel has crashed. All right, that might give us some pause for concern. So what I'm going to do here is sorry for all these issues. I'm going to go ahead and kind of start from scratch. Problem with notebooks, it's hard to keep track of state of what's going on. And that obviously does happen here. So then I am going to kind of start right here. Right. Load the data up. I'll even call this. I can change this to markdown. So I say start here. Import pandas as PD. And let's take the practices. Take that. And get the prescription descriptions. Load in the chem data. Flag our opioids, and I get a name error because I need to, let's see, where are those opioids defined? Fine, right there. Okay, ran the scripts and the chem. Then I can find the opioids per practice. So group by, call this opioids per practice. Scripts with chem, group by, practice is opioid. Compute the mean. And I want to compute the relative opioids per practice. So relative opioids per practice, and set that equal to opioids per practice divided by the global average. Sorry, subtract by the global average. And I can do my standard error per practice. Scripts is opioid. Compute the standard deviation and divide by the square root of the count. So scripts with chem, let's ask for practice and do value counts star 0.5. I think I called this scripts with chem. And I can say opioids score is relative opioid per practice divided by the standard error. And now I can use this as a check opioid score. I think this might be slightly different from before. And then we can say we set the index to code. We got to figure out the unique practices. So we're going to go ahead and copy paste that code. Let's see, right there. Sort by values, drop duplicates, subset on code, keep first, and then set index to code so I can add that z-score column. And then I can say unique practices, and I can say count. And that was scripts. And I can say practice value counts. And opioid, what I call it, opioid score. Let's see how this turns out. And say unique practices. Sort values by the z-score, and we'll say head 100. We got to sort values by default. Say ascending equals false. And there we go. I'm not sure what happened there. I had messy code up above. That's what happens when we're trying to do lots of things at once. But if I clean everything out and I start from scratch, then I think I got what I want. And let's go ahead and put my code where my mouth is. I'll call result unique practices, and I say name, z-score, and count. I can say n largest. It's another way to go about that. N largest on z-score. And how many? 100. Let me just copy the greater cell. And so I call this result. And I get a value 1. All right, sorry about that. Thank you for your patience. Sometimes it helps just to start from scratch. All right, any questions people have before we move on to scripts growth? This one should go a lot smoother. All right, thank you for your patience. And we will. One of the things I want to do after we wrap this up is put these into nice functions, so it's a lot more readable code. Problem with these notebooks, we can run things out of order, and there's probably I'm doing something elsewhere that I just did as a demonstration to make a point, and I forgot to remove it, forgot to comment it out. So thank you for your patience. And now we found the most anomalous practices. So you can imagine this would be great because if we have a new data set for prescriptions for a new year, for a new quarter, we can run this script and we can figure out who's maybe prescribing too many opioids. Sorry, I see a quick question here. Quick on the application, do we need to do the technical assessment again? Yes, you do need to do the technical assessment. However, the only criteria we use, whether you're in Unit 2, is based upon you completing Unit 1. So technically, you can score a 0 on the technical assessment and still get in because the criteria of admissions is whether you complete Unit 1. But hey, if you're in Unit 1, you know how to do the technical assessment. So I'd give it another good shot. How about that? Another good shot. And ideally, you should do better, right? Because you're going through this course. But yes, you still need to do the technical assessment. Why items has no role here? Well, items has no role here. Yeah, I think in our calculation of opioids, we really should have incorporated items. I agree. Because the items field represent, well, how many were issued at that time. So you do have a point. So a criticism here is we should include items. I do agree with you. We didn't for this problem. But in real life, that probably should have, we should have incorporated items. Maybe a sum of how many, because you might fill out a prescription, but it might be a box full of opioids. I doubt that happens, but there might be different prescription levels on items. So yeah, that's a good point. I guess we don't do that, maybe perhaps for simplicity reasons. Okay. Anything else we want to bring up before we move on to Q5, which, trust me, will go a lot faster, a lot smoother. All right, there could be other questions, so I'll keep an eye on the chat, so do bring them in. So for this question, we are looking for prescriptions in which had an unusual higher level of prescribing them. So for example, maybe some drug, I don't know, Tylenol, for example, is prescribed, maybe represents, I don't know, 5%. 5% prescriptions are, let's say, Tylenol from 1 year. And the next year, it jumps up to 10. That's a big jump. So we're looking for here, are there certain drugs that for some reason are being prescribed at a higher rate than before? And we're going to say that the percent growth is equal to the prescription rate, script rate, let's say now, I'll call that 1, minus the initial prescription rate, over the prescription rate from before, the initial prescription rate. Of course, multiply by 100 if we want a percentage. So that's the equation. So for example, if we were prescribing something now at 7%, 7, and now it's 5, and it was 5 before, then it'd be 2 over 5 times 100. Yeah, so you can imagine we can use this for internal audits, exactly. So it would be 40%. So it's a great increase. So hey, you would flag that, and maybe that's okay. Maybe that's because it's a new drug or the old drug was ineffective and it makes sense while there's widely adopted. But the whole point here is not to jump to the conclusion that something bad is going on, but just to flag it so we can further investigate. Maybe we ourselves won't investigate it, but we tell our supervisors, who then send their team to further investigate. And we can simplify this equation here. We can say script rate script rate 1 over script rate 0 minus 1. We can just simplify that equation through some algebra. So the ratio of the prescription rates from now to before minus 1 times 100 should give us this percent growth. So, all right, so we can tackle that. And now what I got to figure out is I've got to figure out this percent growth. Well, first I got to read in. So we're going to read in the data set from the previous year. So DW data, and I say 2016. That's the previous year. And now I got to figure out this calculate x1 minus x naught divided by x naught, which is just equal to and this is great because the indices are the BNF name. So this here tells us how many prescriptions were prescribed for each BNF name. So we can go ahead and say, let's call this percent growth. And I can say scripts BNF name value counts. So this is the current rate, the previous one, minus 1. Now I have this percent growth. And I think we don't want our answers to be multiplied by 100. I think we just want the percentage. So there we go. Here we got a couple NENs. Any guesses why we get NENs here? What could be going wrong there? Not going wrong, but what do you think could be happening there? Why get NENs? When I do operations with series, and if there is an index that doesn't exist in one that does in the other, it goes to 0. Yeah, so new drugs, exactly. So new drugs in 2017 is probably the source of those NENs. They were never prescribed in the previous year, so we got to fill in a value. We fill in with NEN. We'll keep that in mind because there might be at some point need to remove NENs. And we'll go ahead and rename this. Notice the name, BNF name. That's a little annoying. So we can change the name very easily. We can say name, set that equal to, I don't know, PCT growth. Okay, so now we figure out the percent growth for the BNF name. So we got two pieces of information there. We got the name and the fraction. We got to bring in the count. And this count here is, let's see, the count from 2016. So I can say my PTC growth, and when I add in, what I could do, I can say raw count is script 16, and I say BNF name value counts. So that's my raw count. I can even index one of those. Key error. Maybe it doesn't exist. I don't know why there's a double slash there. Oh wow. So raw count. So now we have these two series. We have one that has the BNF name and its percentage. We got it, and we have here with the raw count. And since they share the same indices, we can easily merge those together. So I can say PTC growth, and I can convert it to a data frame. I can easily convert a series into a data frame. And then I can say, I'll call this result. And then I can say result. I can say raw count is equal to raw count. And this works out because, let's go ahead and make sure, examine our results. We got the raw count, the percentage, and the raw count. Now let's sort these by values. Let's sort values by PTC growth. Ascending equals false. Let's check that out. All right, so we have our raw count and our percent growth. So the trick here is that we can call the toFrame method on a series to get a data frame of that series. Just only has one column. And now we can easily add that new column. So here we're using a lot of exploiting the fact that we can easily add a column to a data frame if they share the same indices. We do sort by values and we see our query here. But notice a lot of the great growth is a result of having such a small raw count. Right? This one here is 22, so that's, understandable. But a lot of these have very small raw counts. And in fact, in the solution, we say, hey, we have to have at least, I think we have a limit there where we say, let's see, filter out any items that were prescribed less than 50 times. So we got to filter that out. So what I can do here is I can say query. I can do this because this returns a new data frame, so I can call the query method. The query method makes it very easy for me to filter out my data frame. So I'm going to say raw count must be greater than 50. So now if I look at my results, then at the very top is this Butek transdermal patch at a raw count of 62 and a percentage growth of 3.5. And that, I think, matches up very closely with the sample solution. So I think we're on the right track. We're not quite done yet. What we need to do next is we can call this result. I'm going to call this script anomalies. No, I'll call this result. Not very creative today. Result and head. All right. And then what I can do next is notice the greater ones, the top 50 of the greatest, the largest growth and the largest shrinkage. So we want both ends of this data frame. This data frame is rather large. We want both ends, the top 50 and the bottom 50. So I got to be able to concatenate the first 50 and the bottom 50. And every time I find myself wanting to concat data frames together, bring them together perhaps vertically, I should look into the PD concat function. So I can say script growth is equal to PD concat and concatenate result head 50. Remember that head returns the top 5, a data frame of the top 50, sorry, the top 5 rows, but that's the default. If I say 50, it'll give me the top 50. Then I can say result tail and give me the bottom 50. So this pdconcat will put those together. So now if I say script growth, I have the top 50 and the bottom 50. However, I have these missing values. I probably don't want them. I'm going to scrub them away from our process, no problem. We can go ahead and add this here. Notice we're chaining together these method calls, so I can say drop NA. Drop those missing values, repeat this here. I still have those missing values. Because there was an error here. Because there's no such thing as drone, this is drop NA. Run that there, and now they're missing. And then what I can do is, well, I can reset the index. Reset index. And there is my top 100. And then I can say script growth and select the index, the percent growth, and the raw count. And then submit that to the grader. Looks like I'm off by 0.01, so oh well. I'm not going to stress myself too much about that. There's something I still want to do with this question. I still want to clean it up a bit to show you how we can go ahead and nicely format our data analysis. Sometimes we get very messy working on Jupyter Notebooks, but we'll go ahead and clean this up. And we'll go ahead and exploit method chain. So that's all I've got for today. I'm a little bit over. So we'll pick this up tomorrow and then finish up with rare scripts and set ourselves up to work on a little more interesting things for the last 2 weeks. So with that said, guys,